In this example, we're going to be using long division to divide the polynomial p of x by this polynomial d of x. So, first we're going to have to set it up. So we're going to use the division bar symbol. We'll have our divisor, the x plus 3, out in front. And our dividend, x to the third plus 5x squared plus 6x plus 9 underneath. Now you do want to make sure you're not missing any of the exponents for the dividend. So 3, 2, 1, none. We've got to make sure we start with our highest exponent and aren't missing anything as we go from highest to the lowest exponent. If we are, we need to put a placeholder. Now that we have it set up, the first thing we're going to do is we need to take our leading coefficients for each of the current polynomials and divide them. Not leading coefficients, but leading terms. So we'll take our x to the third and we'll divide it by x, which is x squared. We're going to write that on top. And just like with regular long division, whatever you write on top will then be multiplied by our divisor, writing underneath the dividend. So we're going to take x squared, and we're going to multiply it by our x plus 3, and we're going to write it right underneath. So x squared times x is x to the third, and x squared times 3 is 3x squared. Next thing, just like in regular long division, once we get this product, we shall subtract. So x to the third minus x to the third is, well, they'll just cancel out and make 0. And then we have 5x squared minus 3x squared, which would be 2x squared. Then, just like in regular long division, we bring our next term down and repeat the process again. Take our current leading coefficient. Our current leading coefficient is, or leading term is 2x squared, and we'll divide it by the divisor's leading term, giving us 2x, so 2x will be the next term. And once again, we'll take our 2x and multiply it by our divisor. And that's the next thing we will subtract. So 2x times x is 2x squared, and 2x times 3 is 6x. And we shall subtract. 2x squared minus 2x squared cancels out. 6x minus 6x cancels out as well, forming 0 or 0x if you feel you need the placeholder. Sometimes it is helpful as you're going down through long division. In this case, it's not really needed because if we bring our next term down, we have plus 9 or positive 9. There are no more x's, so we can't really continue with the long division process for polynomials any longer. So 9 will just be our remainder. And we can rewrite our answer in one of two ways. X squared plus 2x with a remainder of 9. Or you can write it as x squared plus 2x plus 9 over the divisor, x plus 3. This is essentially where mixed numbers come from, is dividing like this. And for higher level maths, it's usually preferred to have it as the version on the right. So in this example, we're doing by long division. We are dividing p of x by d of x. So to start it off, we have to set it up. We'll put our divisor out in front. 2x plus 3 is our divisor. And our dividend, 8x cubed plus 27, will go underneath. However, this time we are missing some of the degrees. We have x to the third, which means we need every exponent from 3 downwards. We don't have any x squareds, so in order for the things to line up, we need to put plus 0x squared. We don't have any x to the first, so we'll put plus 0x. And then our x to the 0, in other words, the constant terms, we do actually have. So you need everything from your highest power term all the way down to x to the 0. If you're missing it, you must put a placeholder or things won't line up. With that being said, let's go through the process. So the first thing we need to do is take our leading terms and divide them. So we're going to take 8x to the third and divide by 2x. If we do that, we get 4x squared. So we'll add 4x squared on top. And then we'll multiply our divisor by 4x squared to get what we subtract. If we do that, we're going to have 8x to the third plus 12x squared, which we will subtract. The first term should always cancel out. 8x cubed minus 8x cubed is 0. And 0 minus 12x squared is negative 12x squared. Okay, repeat the process after we drop down our next term. So plus 0x comes down. And we'll repeat the same process, taking our leading terms. In this case, it's negative 12x squared divided by 2x, which will give us negative 6x, which we'll add to the top. The next thing we'll do is we'll multiply our divisor by negative 6x. So negative 6x times 2x plus 3, which will give us our new line to subtract. Will give us negative 12x squared minus 18x. We'll now subtract this. So negative 12 minus negative 12, double negative makes it plus 12. So they're going to cancel out. And then we have 0 minus negative 18. The double negative makes it really plus 18. So 0 plus 18 is 18x. Be careful of double negatives as you're going down through this process. We'll next drop our next term down, the plus 27. And repeat this one more time. So taking our leading coefficients, which are currently 18x and 2x, and dividing them. I said leading coefficients again, I meant leading terms. If we divide them, x's will cancel out and we'll get 9. So plus 9 on top. Multiply our 9 by our divisor, 2x plus 3, to get our new line, which will give us 18x plus 27. Then we shall subtract. 18 minus 18 cancels out. 27 minus 27 cancels out. So we have 0 overall. There's nothing left to bring down. So we have no remainder. Our remainder will be 0. Which makes our answer 4x squared minus 6x plus 9 without a remainder. So in this example, we're going to be using synthetic division. Synthetic division is kind of a shortcut to long division, but it has its limitations. Synthetic division can only be used if you're dividing by a linear polynomial. For example, x minus 3 is linear because there's no exponents with what we're dividing by. You can also do it, or you can also use synthetic division if it's 2x minus 3 with a coefficient that is not 1, but it does get more complicated. So for the most part, it is mostly used whenever it is dividing by something in the form of x minus a number. That's mostly when synthetic division is used. But it can be used if there's a leading coefficient with the divisor. Okay, for the setup for synthetic division, what we do, and this exact notation of how to represent it looks differently depending on where you learn it, but I learned with a bar like this, kind of an upside down division line. There's 2 rows in this little bracket, and then 1 number outside, and we'll also have numbers on the bottom. So as you're setting it up, give yourself spaces for those. Along the top row goes the coefficients with each of the degrees, or each of the terms. Remember that if you're missing any exponents, you need to put placeholders for those powers. So our highest powered term is the 2x to the third. So we'll put 2 for the x to the thirds. We'll put negative 7 next for the x squareds. We don't have any x to the first, so we'll put 0 as a placeholder. And then negative 4 overall. And just as a side note for notes purposes, I'm going to add the powers right above it, which is not actually necessary for the setup. I'm just doing this for the purpose of notes. There we go. So those are the powers. Now out here, what we'll put out here to get it set up is we'll put the root for this corresponding factor. Now the root, if the factor is x minus 3, then the root is just the opposite of that, which is 3. So 3 is going to go out here. And that is it for the setup of this. Now we just have to walk through it. The first thing we need to do to start doing the division is we'll drop the first number all the way down to right below the bar. Then it's just 2 steps. Multiply, add, just repeating until we run out of numbers. So what we're going to do is we're going to multiply the 3 and the 2, and we'll write it in this space here. So 3 times 2 is 6. Now we're going to add vertically. Negative 7 plus 6 is negative 1. And we're going to repeat that process, still taking our 3, multiplying it by our new number, and writing in the next blank. So 3 times negative 1 is negative 3. And then add vertically, 0 plus negative 3 is negative 3. Repeat, multiply, so negative 3 times negative 3 is negative 9. And then add vertically, we got negative 9 plus negative 4 is negative 13. So that's the process. Now we just have to pull out and interpret this as far as our answer. Since our original exponent, original degree of the polynomial was 3, and we're dividing by an x to the first, that's going to reduce the overall degree of our answer by 1, making our first term x squared, our second term would just be x to the first, our third term would be our constant term, which does not have an x, and the last term ends up being our remainder. So overall, writing it out, we have 2x squared minus 1x, or minus just x, minus 3, with a remainder of negative 13, or minus 13 over x minus 3, which is more common when it comes to writing it for algebra 2. But you can also write it as a remainder of negative 13. And that's it. Okay, here we have another synthetic division one. So going through the same idea, we have synthetic division bar. The setup in the top row, our highest exponent is 2, so we're going to start with 3, then negative 5x to the first, then 10x, or 10 without the x. And then as far as what goes outside the bar, it's the opposite sign. So we have x minus 1, so positive 1 will go out here. Then to start the process, we'll drop the 3 down and repeat multiply, add, multiply, add. So 1 times 3 is 3. Add vertically, we get negative 2. We'll multiply, 1 times negative 2 is negative 2. And then add is 8. Last number ends up being the remainder. And since we started off as an x to the square, or x to the second, I know that our degree will be reduced by 1, making this x to the first. So we have 3x to the first minus 2 plus our remainder of 8 divided by x minus 1. And that's it. Okay, in this example, we're going to explore kind of the idea of the remainder theorem. We're going to check out what the value of P of A is and how it's related to the remainder when dividing P of X divided by the factor X minus A. So in part A, we're going to use synthetic division to check out the remainder of our polynomial P of X divided by X plus 5. So setting up synthetic division, our highest exponent is x to the third with a leading coefficient of 1. Then we go to x squared, which has 10. Then x to the first, 29. And then no x. Our constant term is last. This one we didn't need any placeholders for. The number on the outside will be the opposite of our binomial factor, so it's x plus 5 there, so we'll put a negative 5 outside. To get it started, we'll drop a 1 down. Then we'll repeat the process, multiplying, adding, multiplying, adding. So negative 5 times 1 is negative 5. 10 plus negative 5 is 5. Then negative 5 times 5 is negative 25. And then adding, we get positive 4. Then finally, negative 5 times 4 is negative 20. And if we add this one last time, 24 plus negative 20 is 4. Our remainder is 4. Now we're going to compare this to what f of negative 5 comes out to be. So if I replace x with negative 5, and go negative 5 to the third power plus 10 times negative 5 squared plus 29 times negative 5 plus 24. And if I quickly simplify this, or as fast as I can, I know this is negative 125. Negative 5 squared is positive 25, and positive 25 times 10 is positive 250. We have next negative 5 times 29, which is negative 145, and then plus 24. Continuing to try to simplify addition and subtraction. Negative 125 plus 250 is positive 125. Positive 125 then minus the 145 ends up with negative 20. And then lastly, plus our 24, which overall results to be 4. And you can see that with that, the result that we had for both part A and part B is the same, and that's one of the properties that was shown earlier, is that the result of this division, the remainder, will be the same thing as if you plug in the value into the polynomial. Okay, so in this example, we're going to use the factor theorem to determine if x minus 6 is a factor of this polynomial. The factor theorem says it is a factor of the polynomial if p of 6 equals 0 or if the remainder is 0. So we can approach this in one of two ways. We can set up the synthetic division with 1 as the leading coefficient, negative 8 for x to the third, 16 for x squared, negative 23 for x to the first, and negative 6 for no x. And on the outside, we would have our opposite term of our divisor, which would be positive 6. And just following through, drop it down 1. 6 times 1 is 6. Negative 8 plus 6 is negative 2. And then just multiply to get negative 12. We'll add again to get 4. Multiply again to get 24. Add vertically, we got 1. And 6 times 1 gives us 6. Negative 6 plus 6 is 0. So our remainder is 0. According to the factor theorem, if the remainder is 0, then this x minus 6 is a factor of the polynomial. I could have also checked it out in this way. I could have also taken the root for this, which would be positive 6, and plugged it in for x, doing 6 to the power of 4 minus 8 times 6 to the third plus 16 times 6 squared minus 23 times 6 minus 6. If I were to go through and type that in and simplify it all out, we would get the result of 0 according to the remainder theorem, and that also translates to the fact that 6 would indeed be a root of the polynomial, which in turn means that x minus 6 is a factor of the polynomial. Okay, so in this example, we're going to use synthetic division to divide 8x to the third minus 12x squared plus 16 by 2x minus 1. This is a little bit trickier because synthetic division is mostly used to divide by x minus a, and unfortunately there's a leading coefficient here. However, we can do some rewriting to allow us to use synthetic division to actually divide by 2x minus 1. Now, let's first look at this as a fraction. 8x to the third minus 12x squared plus 16. And on the bottom we have 2x minus 1. So I'm going to go ahead and rewrite this so that the bottom is in the form of x minus a number. And since this coefficient on the bottom is 2, I'm going to multiply the bottom polynomial by 1/2. That will cancel out this 2 and make it just x minus a number. On top, I have to do the same thing to balance it out. So I'm going to multiply this polynomial by 1/2. In doing so, it turns into 4x to the third minus 6x squared plus 8 over multiplying by 1/2 on the bottom. 1/2 times 2x, the 1/2 and 2x will cancel out, leaving me with just the x. And then 1/2 times the negative 1 is minus 1/2. So I've rewritten the polynomial now, and I'll set up synthetic division. So going through for synthetic division, my root is again the opposite of what I have in the bottom, so I have x minus 1/2, so the root on the side will be positive 1/2. My coefficients, starting with the highest exponent of 3, will be 4x to the third, negative 6x squared. We are missing the x to the first, so I'll put 0 as a placeholder, and we have 8. Synthetic division will drop the first term down, 4. Then it's just multiplying and adding like normal. If you get fractions during this process, you may actually even get fractions here for the coefficients. I chose one that didn't have fractions to make it a little simpler to go through the process. But you can get fractions here or down here, really just anywhere. Don't be afraid if you do get fractions for this. It happens. I did choose one that doesn't have fractions to make it a little easier to go through for the first time. But then we just repeat the process. 1/2 times 4 is 2. Multiply, add, multiply, add. So negative 6 plus 2 is negative 4. Again, we'll multiply. 1/2 times negative 4 is negative 2. Add vertically, we got negative 2. Multiply again. 1/2 times negative 2 is negative 1. And then add vertically, we got positive 7. So here's what we have. We have 4x squared, reducing our first exponent, our first degree, by 1, minus 4x minus 2, plus our remainder of 7 over x minus 1/2, because that's what we actually ended up dividing by when we did the synthetic division. But that's not our actual divisor. Our actual divisor was 2x minus 1, so we have to go back and kind of undo that division we did at the beginning. So at the beginning, we multiplied the top and bottom by 1/2, ending up getting us this fraction here. But we no longer want that fraction. We want to turn it back into 2x minus 1. So what we're going to do is we're going to do the opposite of multiplying by 1/2, which is multiplying by 2, multiplying by its reciprocal. So I'm going to multiply our remainder there, that fraction for our remainder, by 2 on top and bottom, which will turn it into 4x squared minus 4x minus 2, with our remainder being 14 over 2x minus 1. And there we have it for synthetic division. There are a couple other ways to go about using synthetic division. I think only one other way of going over synthetic division with the leading coefficient not being 1, but this is just an example of it. And again, you can have fractions just about anywhere when you're going through this process. Oftentimes there are fractions right here. This particular one is whole numbers, just to make it a little easier for the process, for this part of the process. But yeah,